For as long as humans have gazed at the night sky, Betelgeuse has captured our attention. Situated on the shoulder of Orion the Hunter, this massive red star glows with a distinct reddish hue. It's one of the largest and most luminous stars we can see with the naked eye. But Betelgeuse isn't just impressive, it's also dying. In 2019, something strange happened. This star suddenly dimmed a lot to astronomers around the world. It was an alarming change. Many speculated that it was about to blow into a supernova, lighting up our skies for several weeks. However, Betelgeuse gradually brightened again in early 2020, back to its normal appearance. But the event raised even more questions than answers. Why did it fade so dramatically? Why has its brightness always been so irregular? Could something else be interfering with its light? Now, years later, astronomers have found a missing piece of the puzzle. They have finally discovered another star locked in a close fateful orbit with Betelgeuse, confirming a hypothesis that was proposed more than a century ago. This groundbreaking discovery is going to reshape our understanding of Betelgeuse. So, how did astronomers finally manage to spot the elusive companion of the red supergiant Betelgeuse? Why did it remain hidden for so long even from our most powerful space telescopes? Finally, and most importantly, what fate awaits this tiny companion when Betelgeuse eventually goes supernova? The story of the discovery of Betelgeuse companion is quite interesting. It all began with the great dimming of 2019. Over the course of a few weeks, Betelgeuse brightness dropped to just 35% of its usual brightness. Astronomers later found out that the dimming wasn't due to something happening inside the star. Instead, it appeared that Betelgeuse had ejected a huge cloud of gas. As this gas cooled, it condensed into dust, which then drifted in front of the star and blocked some of its light from our view on Earth. Betelgeuse soon returned to its normal brightness. But the great dimming episode turned astronomers' attention to something mysterious about Betelgeuse that has always puzzled them: its pulsating cycles. Betelgeuse is a bit of a rhythmic breather. It pulsates, meaning its outer layers regularly expand and contract like a slow-motion heartbeat. But here's where it gets interesting. It doesn't have just one rhythm. It has multiple overlapping cycles. The first is the main pulsation cycle of 400 days. Roughly every 400 days, the star slowly swells and shrinks. This is due to changes in pressure and temperature in its outer layers, causing it to brighten and dim slightly over time. But there's another much slower cycle, one that's far more puzzling. About every 6 years, Betelgeuse gradually brightens and dims again, though much more subtly. And despite decades of observations, no one knows exactly what causes this longer rhythm. It wasn't just Betelgeuse brightness that changed. Its motion did, too. Specifically, astronomers noticed changes in its radial velocity, the speed at which the star moves toward or away from us along our line of sight. To picture this, imagine watching a car drive straight toward your camera and then away from it. That direct in and out motion is what radial velocity measures, not sideways movement, just forward or backward from our point of view. Astronomers detect this kind of motion using a phenomenon called the Doppler shift. When a star moves toward us, its light waves get compressed, shifting light slightly toward the blue end of the spectrum. If it moves away, the light stretches out and shifts toward the red. By carefully measuring how the star's light shifts over time, scientists can figure out how fast it's moving along that line. But here's where it gets interesting. If a star's radial velocity changes in a smooth repeating pattern, it's usually a sign that something is orbiting it, like a planet or another star. That's because of gravity. When a star has a companion, the two don't just orbit separately. They both revolve around a shared center of mass. As a star gently gets pulled toward and then away from us in its orbital dance, its light rhythmically shifts between blue and red. In Betelgeuse's case, this exact pattern appeared. Astronomers dove into over a century's worth of data, analyzing both modern radial velocity measurements and historical spectroscopic plates, some dating all the way back to the early 1900s. What they found was astonishing: a consistent repeating cycle. The data revealed that the star's radial velocity wobbled in a smooth wave-like pattern roughly every 2,100 days, which is about 5.78 years. This finding was a turning point in the story. For the first time, scientists had strong long-term evidence of two separate behaviors. Betelgeuse brightness and its radial velocity both changing on the same time scale of about 6 years. That kind of alignment wasn't likely to be a coincidence. It strongly hinted that something was orbiting Betelgeuse and tugging on it, affecting both its motion and its light. With this discovery, the binary theory gained fresh momentum. The evidence was mounting and now astronomers were more confident than ever. A companion star had to be there. It was no longer a question of if. It was only a matter of when they would finally be able to see it. At the same time, another research team approached the mystery from a different angle. Their findings pointed to a fascinating possibility. The suspected companion star might occasionally pass through Betelgeuse's extended bloated atmosphere. As it moves through this region, it could disturb the surrounding gas and dust, causing fluctuations in how much light reaches Earth. But there was still one big problem. No one had actually seen it. Even some of our most powerful observatories, like the Hubble Space Telescope and the Chandra X-ray Observatory, had scanned the region around Betelgeuse in search of a companion. Yet, they found nothing. This suggested two possibilities. Either the companion is extremely faint or it's orbiting so close, just a few astronomical units away from Betelgeuse, that it's completely lost in the star's brilliant glare. In other words, if it really exists, then it's been hiding in plain sight all along, shrouded by the brightness and chaos of a dying supergiant. But there was a silver lining. Even though the companion hadn't yet been seen, the new models provided something incredibly valuable: a prediction. They calculated when and where the companion would be easiest to spot. According to their results, the companion was expected to reach its maximum angular separation from Betelgeuse in late 2024. This means it would appear farthest from the star in the sky at that time, making it just a little easier to distinguish from Betelgeuse's overwhelming glare. The models didn't stop there. They also estimated how bright the companion might be and its exact position relative to Betelgeuse. With all this information in hand, astronomers now had a rare opportunity, a brief, well-timed window to try to finally capture a direct image of the elusive star that had hidden in plain sight for so long. And finally, the moment arrived. A team led by Dr. Steve Howell prepared to test the predictions. On December 9, 2024, the Gemini North Telescope in Hawaii turned its gaze toward Betelgeuse. Mounted on it was a powerful instrument called the ALO, a high-speed camera designed for one very special task: capturing details too fine for ordinary telescopes to see, especially when they are blurred by Earth's atmosphere. When the Gemini team observed Betelgeuse in December 2024, they saw something remarkable. Just 0.0505 arcsec from the center of Betelgeuse disk, a distance equivalent to the apparent width of a human hair. From 10 kilometers or 6.2 miles away, a tiny faint point of light appeared. This separation translates to about 4 astronomical units, or roughly the distance between the Sun and Jupiter. The object was about 6 magnitudes dimmer than Betelgeuse, so faint that it had remained completely invisible in earlier images, including those taken in 2020. But in December 2024, it finally appeared. And not just anywhere, it showed up exactly where astronomers had predicted the companion would be based on orbital models.